Hi, I'm Leonard from Lenco Solutions, and today I want to discuss how you should do your wiring of your ride-on-one project. Basically, it will be made in two parts because you can split the wiring basically in two halves. The first half will be what is essential to riding your ride-on. We will discuss hall sensors, IMU, stuff like that. And then secondary, it's more the non-essential things like lights, like stuff like that. Um, I will be filming most of this very close, so you won't see my face all the time. Okay, so now you can see the inside of the electronics box of the ride-on-one. And as you can see, there's quite a lot going on. So I can understand that it can be overwhelming. Let me just try to guide you through understanding just how it works, and then wiring will be super easy. Right, so we have the battery on the other side, and the main cable for the power supply is coming out of this hole on the bottom. And there's two extra wires, and I will discuss this later. But basically it is used to power all auxiliary systems. Now, the first thing you want to do is to be able to switch the board on and off, right? So this is the first reason why I really like working with the Spin10 product, because this is actually the Flipski 7500 VESC, which is a great VESC. That there's just a few drawbacks, and one of them is that it has no anti-spark. So you need to install your own anti-spark. So in this case I have the Flipski anti-spark as well. It is 14S. If you use our battery, which is 16S, this won't be sufficient. So watch out with that. It does a lot of amps though. I think it's actually rated for something like 280. Yeah, it says 280 and bursts of 800 amps. I'm not sure if these wires could actually do that, but it says it's rated for that. And anti-sparks are also really tricky things, because if you would connect them without the switch plugged in, or you would remove the switch while it is still plugged in, you will probably ruin it completely. And during development we have had some weird issues. If there's some weird power surges going on, you might ruin your anti-spark. So be careful with that. But basically the idea is pretty simple. The power button switch is right here. These wires come out of the power button. You can just connect the anti-spark like this. It's actually really simple. It is marked in and marked out. Right, so battery side. Like this. And just, plug it straight into the VESC. Most important part done. Right, so there's actually a really nice spot over here where this fits really nicely, but I'm gonna remove it again because it's gonna make to make it much easier to watch. But that's basically the power circuit. Now, and the other most important wires are of course the phase wires. If you look at our motor cable, there's lots of small wires and 3 big ones. And you guessed it, the 3 big ones are the phase wires, and it absolutely doesn't matter at all which one you connect. That's why the Flipski wires also have, they're just black, so you can just connect it. With the Spin10 product, usually there's a difference. Usually it matches the color on the motor cable, so you can connect them. It is handy that you know always in which order you connect it, because if for some reason you disconnect, you still know the way it works, the way you originally connected it. Okay, so the second most important reason why I like working with the spin end product is we need to connect these Hall sensors, and the spin end uses a different type of connector. They actually use the JST connection. I will leave a link in the description to an Amazon product, so you know which connectors they use. But in this case, I can't connect these I can't crimp these connectors myself because I don't know which one they are. They won't tell me which one they are. So I have to solder these wires, and I don't like soldering. As you can see, one of this solder connection has already, it is broken, so I have to redo it. So that's a shame. I like crimping more because it's less connection is always better. So with the spin end I could just crimp my connection and it works every time. The order is actually pretty simple because usually these colors actually match. I do recommend that when you order your motor, you specially request for a temperature sensor, because then you can monitor the temperature of your motor. And then the wiring also becomes pretty easy because each device needs a ground and 5-volt connection. So usually these are also quite logical actually. And also written on most VESCs is each connection. So on the very top it says 5 volts. It is a red wire with the flip-ski connection, and also in the motor cable it is a red wire. So you can just connect the red wire to the red wire. Then all the way in the back it says ground. It's a black wire. Doesn't come as a surprise. So connect the black to the black one. Then the white one is the temperature sensor. It says temp on the VESC, and that's the only sensor wire that we use. And all other it's also white on the motor cable, and all other cables are phase wires, or not phase wires, are Hall sensor wires, and they also match in color. So if you are using this VESC or most other VESC, chances are that you can just solder the connection and keep the same colors. If not, it will, when using motor detection, it will find the right Hall sensor. The foot sensor is a bit more tricky because it's 2 sensors and the wires are straight connected to the sensor part of the VESC. And VESC uses 3.3 volts to measure the foot sensors. It's actually an analog signal going to VESC. So if you check out this connector here, you will find 5 volt, 3.3 volt ground, ADC 1, and then 2 connectors for Bluetooth, and then ADC 2. And we are using the ADCs to connect the foot sensors. So we will use the white wire, which is 3.3 volts. The black one we need to find somewhere. In this case I borrowed it from another connection. It's actually from our CAN bus connection, but the ground is always the same, so it doesn't matter. And here are the 2 ADC wires, one for each sensor. But if you would connect this straight to the foot sensors, chances are that you will have a lot of noise, and it won't be as easy to connect to read a correct value. So I don't recommend doing that. And in the beginning of development, we made this board, which actually houses an Arduino, but it has a separate circuit, and as you can see it has 2 pull-down resistors, 1K pull-down resistor, and all it's doing is when it's not in use, it will pull all noises down to the ground connector, and it will make it a lot less noisy. And later in the video I will explain what's the easiest way to make this connection, but in this version of the Ride On Complete we use this board which has an integrated circuit, so you can just connect this connector here sorry, here, and you can connect the foot sensor straight in here. The order right now isn't that important, but what's important is that it will have 4 wires as well. Each sensor has 1 plus and 1 minus, so connection is pretty straightforward. And then when setting up VESC, you can just adjust your threshold value, and the world will be a happy place. I'll explain what all the other things actually do. So let's start with the easiest one, which is the Bluetooth module. The Bluetooth module, also sold by Spinten. It's actually quite easy to connect, because to connect the Bluetooth module, just use the following wires: ground, RX, TX and 3.3 volts. When you open this installation, because I recommend soldering the wires straight to the board, it will have the same letters and numbers written on here, so you could just connect the two. It's actually really easy. And this is a Flipski Bluetooth module, which has an antenna with like a sticker. But you can buy the Spinten one, which has an integrated antenna, which is a bit cleaner, makes for a bit less wiring. So what are all these other wires doing here? Well, because I like what my board warns me when the battery is low. You want the speaker. You could connect this speaker straight to the servo port and use the original firmware. It will tell you, you can turn it on in the Float app, and it will warn you for some stuff. You can actually set up some thresholds, stuff like that. I went ahead and used the actually Arduino module to program my own threshold. It is connected through CAN bus. It constantly gets the signal from the battery state, and when it's low, it will have a tune to warn you for a low battery. But because if you turn off the board, you also want every auxiliary thing like the Arduino, but also of course the lights, because the lights are also powered through Arduino. You want actually to power these down. So what you want is a solid state relay, which you can see right here. And the wires we discussed earlier, straight from the power wires from the battery, are actually connected. So they're before the anti-spark. It's really important to always connect your wires, feed wires to auxiliary systems before the anti-spark. Otherwise you can ruin your anti-spark. And they are connected straight into this. So the plus goes into the solid state relay, and the ground will go into this voltage regulator. This is actually a voltage regulator. It's straight off the shelf. Same goes for the SSR. It works. It can't do the 20S batteries, but I will discuss more about this later. And then, so now we have power, we have a switch. 5 volt comes out. It will power the Arduino, it will power your LEDs, the Arduino will power your speaker. But right now we still need to connect the CAN bus signal. So through a bus connection, I think it's SPI bus, you connect the Arduino to a CAN bus module, and the CAN bus module can talk to the VESC and get the signals it needs. All right, let's check out the ride-on light module. This is actually quite a small PCB, as you can see. And it integrates all the components that you saw earlier, which were quite large. This is actually the solid state relay. This is the step down converter. It will give you nice and steady 5 volts out. This is a microcontroller. The microcontroller will do all the logic. same as the Arduino did. And this is actually the CAN bus module. This is the separator. This is a pin we use for programming. This is the speaker, and it actually integrates a lot of wiring, so it makes connecting it quite easy. Let me guide you through everything that you need to know to connect this board. I actually think it's quite simple. All the information is also written on the board itself, and on the bottom it will have all the letters and symbols that you need to connect it. So even without me explaining it, you can connect it. This is the VESC CAN connector. It has 4 wires. This is the plus, this is CAN high, CAN low, and ground. And simple as that. It is marked right here. It has the connections on the bottom. That's it. This is for the battery connection, so it is battery voltage in. And plus, minus, that's it. This is actually the connector to connect your LCD screen to indicate where the voltage of your battery actually is. This is the first LED, this is the second LED, so front or back. I'm always confused, but I think that this one is the front LED, but don't pin me down on that. Then we have foot sensors going in, foot sensors going in, so it has VESC ADCs, and then the foot sensors themselves, which go to your foot sensor. And on the back we have written what the connection actually is. So for the foot sensors themselves, it's plus, foot sensor 1, foot sensor 2. And for the VESC, it's actually plus, minus, sensor 2 and sensor 1. Actually, it doesn't really matter which one is number 1 and which number 2, because it doesn't matter. It only looks if it sees 1 or 2 sensors, and that's it. So yeah, that's actually how simple it is to wire it when you're using this light module. Now it comes with this this box. It's quite easy to 3D print actually. You can also always order it, of course, and you can just screw it down. It has a little cover because this is actually a prototype. Won't quite fit right, but you get the idea. In the normal version it fits really well. These connectors are not that straight on there, but you know, when they machine assemble it, it will be perfect. So it will fit perfect. The holes will be, of course, pre-drilled in the the bottom plate, and you can just screw it down, and it will make your life a whole lot simpler. It's really reliable. I really recommend getting it. Really proud of this product. And then there's only one thing we are left to discuss, which is IMU. Alright, now let's discuss actually the most important part. And it is actually the IMU. So the IMU, in this case, is located right here. And what the IMU does, it is a gravitational sensor which measures in 3 directions. So one is actually measuring like perpendicular on the sensor, one like that and one like that, and which means that you can detect all the movements that the IMU can do. And it is all kinds of things to stabilize the signal on this print. But as you can understand, it is actually quite a sensitive device, so it's kind of hard to get a really nice signal. So if you are using the Flipsky VESC, you need to connect your own IMU, and it should be as close as possible to the VESC that you can, because you want these wires to actually be really short. If you want, you could actually open this VESC up and make make 2 bolt holes and just screw it down, make a little standoff, so you can actually just mount it here and get these wires super short, because it is super important. This distance actually works, but I do actually think it is max, because we had a lot of problems developing this. It uses the same connector as the wires for the foot sensors. That's the same connector. Connecting it is actually really easy. On the bottom is usually same as on the VESC, so it has a 5-volt connection, ground, SCL and SDA. It's the same on the VESC. I use this 5-volt right here. Then there is this 3-volt that we use for the foot sensor, and I think then there is the ground. I like to use the ground straight, because it is such an important circuit. You don't want to miss your get your IMU scrambled during the ride. And then it's marked on the VESC. First is ADC1, then it is SCL, and then it is SCA, I think. Let's see, ground, ADC1, SCL, SDA. So yeah, that's it. You can basically just read what's on there. But because it is such an important thing, that's the final reason that I like that's why I like the spin dents VESCs more, is because they have integrated IMU. So then you just use the internal one, far less chance of getting interference. So you just use the internal one. So again, you can connect the phase wire of the Hall connectors the way you want it. Much cleaner than soldering it. It has an internal IMU and it has an internal anti-spark. Actually, it also uses phase filtering, which I think makes the signal a bit cleaner. So it makes the ride feel a bit smoother. At least for me, that's what I seem to notice. Basically, that's it for connecting your wires. Again, 2 separate wiring harnesses can be defined. For the secondary, I really recommend using the light module. Makes it super easy. Everything is written down here. It gives you very nice functionality. It gives you directional LEDs. It will give you nice animation for the front LED. It will give you a brake light, because when it's decelerating it will light up the rear LED. It will give you a low voltage warning. It will give you a duty cycle warning. So it will make your life a lot easier. It has the built-in pull-down resistors for the foot sensor. Other than that, just connect the Hall sensors. And again, I recommend using the spin tent VESC, because it will also make your life easier. It has built-in anti-spark, built-in IMU, it does phase filtering, and you can get a nice discount. We will give you $20 off if you use our affiliate link, which is mentioned on the website, for all orders above $100. So yeah, it will be a great deal.